Hello guys, this is your fifth problem of homework 4. So the uniform being supported by two rods AB and CD that have cross-sectional areas of 10 mm squared and 15 mm squared respectively. A. Determine the intensity of W of the distributed load so the average normal stress in the rod AB does not exceed 310 kilopascals. And B is the same of A but in the rod CD. We have two different problems, so I'll start with the same approach. First, our known free body diagram. So here I have my tension AB. Here I have my tension CD. And here I have my beam. I recall for our triangular load, I'll have like a equivalent load that is omega times 6 over 2. So 3 omega is my load, and I know my distance is 1/3 from the beginning of my triangle, so 1/3 of the length of the beam, in that case 6. So I can position my equivalent load P, and I am 2 meters from the end C because it's 1/3 of L, and here I have 4 meters until my end A. Now I'll proceed with my sum of momentos around CD counterclockwise is positive. Why I'm doing the sum of momentos around CD? Because I'm just interested in the rod CD. So I know my P, it's doing a momentum counterclockwise, so P times 2 meters, and my AB is doing a clockwise momentum, so it's minus TAB times 6 equals 0. So proceeding from here, I know my P is 3 times omega times 2 equals TAB times 6. So I know that my TAB equals W, omega, in that case. Now I know my normal stress equals TAB over area. I know my TAB is the same as omega, so omega equals the normal stress times area. So I know my omega will be the shear stress, that's 310 times 10 to the third, because it's kilopascals, times 10 times 10 to the negative 6, because I'm converting to meters square. So my W equals, I have 310 times 10 to the negative 2, so my omega equals 3.10 newtons per meter. Y is the load, even though my TAB is the same value of W, they don't have the same units. Proceeding to our B. For part B, we're gonna use the similar idea. So we have our free body diagram, our tension AB, our tension CD. We know from the previous slide that we have our equivalent load, that's 3 omega, 2 meters from the end C, and then 4 meters from end A. And then now I'm gonna do the sum of momentos around CD AB, because I'm interested in the rod CD now. equals 0. So I have my equivalent load doing a clockwise momentum, so I have minus 3 omega times 4, because I'm 4 meters from NA, plus TCT times 6 equals 0. So here I have 6 tension CD equals 12 omega, so my tension CD equals 2 omega. Using the same approach for our normal stress is tension CD over our area. We know that our tension CD is 2 omega equals normal stress times area. And here we have omega equals normal stress at 310 times 10 to the third times my area, that's 15 millimeters, times 10 to the minus 6 over 2. So my omega is 2,325 times 10 to the minus 3 newtons per meter, or omega is 2.33 newtons per meter. So this is the final answer for B.